Hello, everyone. It's noon here and we're about to start our webinar. So I'm just going to welcome you and say happy Halloween and tell you a little bit about what you're going to hear from us today. So this webinar is sponsored by CTS Transportation Research Council and the CTS Environment and Energy Council. So a joint webinar. I am Beth Angum. I'm with Bolton and Mink, and I'm a Senior Associate Transportation Project Manager. And I am co-hosting this with Mauricio, who I will let him introduce himself.
Hello, my name is Mauricio Leon Mendez, and I work as a carbon reduction manager for the Hennepin County. And I am the chair of the Energy and Environment Council for the Center of Transportation Studies.
Thank you, Mauricio. A little bit of background on the two councils. So the councils provide a forum for transportation professionals and researchers to exchange information on current transportation issues and trends. And we bring together university faculty and staff with practitioners across both the public and private sectors so that we can participate in and recommend direction for improving the center's research, education, and engagement programs. So James will share a link to the council's information in the chat in case you're interested in learning about more. And just switching gears here to our webinar that we have teed up. Today, we're going to be presenting on updating the Minnesota Stormwater Inspection and Maintenance Resource Guide. And in a moment, I'll share more about that topic, but first I'll have Mauricio cover some housekeeping items.
So we're looking forward to audience participation and questions during Q&A time, which follows the presentations. We encourage you to use the Q&A at the bottom of your screen at any time to type questions or comments for the speakers. During Q&A, you could use the raise hand feature if you prefer. Then we can unmute you to share verbally. Also, this event meets the continuing education requirement for 1.5 professional development hour credits and 1.5 American Institute of Certified Planners, AICP, certification maintenance credits. The PDH form will be uploaded to the chat for anyone who needs it. We're going to cover some fall events. CTS will be hosting our 2024 CTS Transportation Research Conference on November 7th. You can find more information at www.cts.umn.edu. CTS will also be holding 2 other transportation research webinars this fall that you might be interested in. On Thursday, December 5th, from 2 to 3:30 p.m., expanded the transportation workforce, and on Friday, December 6th, from 1:30 p.m. to 3 p.m., unlocking autonomous transportation potential, key insights from the GoMari shuttle pilot. I'm really excited for that one. Information on how to register will be available on the CTS website at www.cts.umn.edu/events/seminars. Finally, if there are any students joining today, could you please send a chat to all panelists with your name? We track the number of students who are engaging in our events. Thank you. Now back to Beth.
Thank you, Mauricio. I would be remiss if I didn't mention the CTF staff members, James DeSoto and Sam Hahn, who are on the call today and make this all happen, really. They make it very easy for us to chair these councils. So now on to the webinar. So in 2009, the Minnesota Stormwater Best Management Practice Maintenance Resource Guide presented guidance on inspection and maintenance activities for stormwater ponds, bioretention facilities, underground treatment devices, underground detention, and infiltration. The maintenance guide was developed as a complement to the Minnesota Stormwater Manual. As you can imagine, since that guide's publication, we have learned a lot about inspection, operation, and maintenance of these and other stormwater BMPs through field applications, practical experience, and research. At this webinar, we're going to share the results from a new project to update, revise, and expand that 2009 resource guide to incorporate over a decade's worth of knowledge gained For example, the guidance was added for inspection and maintenance on iron-enhanced sand filters and nutrient release from bioretention-based practices and stormwater ponds, among others. The revised and expanded Stormwater BMP Maintenance Resource Guide is a nice reference and tool for practitioners to optimize decisions and increase the cost effectiveness of stormwater management. So with that, I'm pleased to present our speaker today, Andy Erickson, who is a researcher and engineer at the U of M St. Anthony Falls Laboratory. He studies water quality in urban watersheds, develops stormwater assessment and maintenance best practices, and designs innovative stormwater treatment technologies. Andy is the co-director of the Cold Climate Center of Excellence for Stormwater Infrastructure Technologies, and he's also the chair of the ASTM International E64 Committee on Stormwater Control Measures. He's also the chair of the U of M Water Council, a fellow at the U's Institute on the Environment, a CTS research scholar, and a member of CTS's Environment and Energy and Transportation Research Council. So with that, Andy, I will turn it over to you.
Very good. Thank you, Beth. Thank you so much for inviting me to be here today. I'm so excited to be with you all to talk about this project to update the Minnesota Stormwater Inspection and Maintenance Resource Guide. I'm also fairly excited to have an assistant help me with the presentation today. Millie, the zombie cat, was pretty insistent about helping with the presentation to ensure I don't miss any super important points. So please keep an eye out for Millie throughout the presentation. And let's dive right into it. So we're talking about urban stormwater runoff management. And this really is, if you look at our urban landscapes, it's how we manage runoff from rain. And really, we're trying to collect, convey, and oftentimes concentrate that stormwater runoff so that we can treat it. It will get centralized and ultimately discharged to our typically surface waters, our lakes and our streams and our rivers. But unlike wastewater treatment or other water treatment systems, it doesn't go to a treatment plant. It actually goes to dispersed stormwater treatment practices. And these stormwater treatment practices look different, and they go by many different names. And actually, you might know them more as BMPs, or best management practices. You might hear stormwater control measures, green infrastructure, green stormwater infrastructure, low impact development, and a few other names that are actually used to describe these practices in other parts of the world. But in reality, they're really just stormwater treatment practices. They're different ways that we capture stormwater runoff and we treat it to remove pollutants and to reduce flooding. We are also trying to mimic or restore some of the natural hydrology that was there before we created all the impervious surfaces that we find in our urban landscapes. So these practices are doing a lot of different things, but they are distributed throughout our landscapes. And just like anything else in our lives, we have to do maintenance to ensure that they continue to operate properly throughout the future. So again, as I said, one of the things that's different about stormwater practices versus other types of treatment is that they are out in the environment. They're not sheltered or protected inside a water treatment plant. They're out in the landscape. And so they experience the elements of the weather without shelter. And as such, there are many, many types of stormwater BMPs out there, and they come in many shapes and sizes. And there's many locations, and that was a point that Millie was very adamant about pointing out, is that there's many of these stormwater BMPs throughout the urban landscape. And if you imagine trying to do maintenance on many different sites all over, you can probably quickly see that that's going to be a challenge. And again, unlike a wastewater treatment or drinking water treatment plant, stormwater treatment is actually passive. It's installed in the landscape, and we as stormwater managers hope that it continues to work. There are no operating staff on site to see when these things fail or see what's causing them to fail. We have to go out and do inspections. We have to be proactive in our inspections to find when these things start to fail. So that's a challenge. And as you can imagine, that also then will increase the cost of maintaining our stormwater treatment practices, because we have to make extra trips out to these very dispersed treatment practices throughout the urban landscape. And I won't get into it today, but it is part of the manual. The cost then goes up considerably. And depending on the size of the practice, your total maintenance cost might become more than your original construction cost within 5 years of the life of that practice. And many municipalities are struggling with that because there's budgets for building new practices, but there's often limited budget for actually maintaining them. And when I was explaining this, Herbert just started to freak out. He couldn't imagine how he's going to be able to pay for the maintenance of all of these stormwater practices within his jurisdiction. Some cities can have hundreds or even thousands of stormwater treatment practices within their purview. So thinking about the maintenance costs is very important, and optimizing maintenance can actually create lots of cost savings for something that already doesn't get enough money as it is. So you might ask, well, why would we need an inspection and maintenance resource guide? Aren't there already tools and training and guidance out there on this? And some might say, well, what about the Minnesota Stormwater Manual? And of course, the Minnesota Stormwater Manual is out there. This is the state design guidance for stormwater practices. It does include some maintenance guidance, but also all of the regulatory requirements around stormwater. And the manual actually has many, many details, but it can be a bit dense. Last I heard, something like 8,000 individual web pages. This is a wiki manual, so it's an online interactive manual. And something like 8,000 pages or more make up the Minnesota Stormwater Manual. So sometimes it can be hard to find what you're looking for. And MnDOT and the local road research board is, as a consequence, funded the development of an inspection and maintenance resource guide, originally in 2009, and then provided additional funding for us to update and upgrade that manual to incorporate everything that we've learned since 2009 on stormwater practices, inspection, and maintenance. Now, I don't want to talk down the Minnesota Manual. It's a Minnesota Stormwater Manual. It's a fabulous resource. I encourage you to check it out if you haven't seen it. Many people look to it as the guide for stormwater, not just in Minnesota, but actually outside of Minnesota as well. There is a link to it here, but honestly, if you just Google Minnesota Stormwater Manual, it's going to come up as #1. It's that popular. So I encourage you to check it out. And this inspection and maintenance resource guide that I'm talking about today is a supplement. It's meant to be complementary to the stormwater manual, because what it does is it focuses in on the specific instructions for how to do inspection, simple assessment, and what to do for maintenance of your stormwater practices. It's meant to be something that after you already have all of this infrastructure within your jurisdiction, what do you do to keep it working? That's what this resource guide is all about. So to do that, I do want to make sure that we're all talking about the same thing when we say operation and maintenance, or inspection and maintenance. And really, the operation and maintenance of stormwater treatment practices really boils down to 3 things. There's inspection, where we actually look for problems. This is a very quick, simple, visual assessment to schedule and select the maintenance that's needed for the practice. This is ideally, you could do this with field crews. We've actually done some surveys, and some of this information is also in the resource guide. We did surveys to understand how people do inspections and what's needed for inspections. And we found that the complexity of inspection itself is very simple. So you can have interns during a summer. You could have a whole field crew of interns that are just going around to do inspections. They would learn a lot about stormwater treatment, and you would learn a lot about the function of your stormwater practices and which ones need maintenance and which ones need maintenance sooner rather than later. And you may find that some of these practices also need further assessment. You may need to do some additional measurements to determine the performance of the practices, because the inspection might say, "Ooh, it's not quite working right," but you might not know why or where. You may want to focus and hone in on the maintenance on certain portions of the practice. And that's where you can do assessment, whether that's point measurements or other data gathering to find out what specifically is failing within the practice so that the maintenance you do perform is specific to the problem and getting at the root cause. And then, of course, you need to do the maintenance. That should all really, the inspection and the assessment leads to what maintenance needs to be done. And it's not just the what of what needs to be done, but it's also the when. How quickly does that maintenance need to be done in order for your practice to be working long term? And maintenance really is the same for everything. It's the same whether you have a bike or a car or a home. These are activities that we perform to ensure the proper function and extend the usable life of your stormwater treatment practices. So that's what we're doing, and that's what we're talking about today. And this is what the manual is all about. What inspection do you need to do? What additional assessment might you want to do? And then ultimately, what maintenance needs to be done? So to understand maintenance, there's really kind of three categories of maintenance, and we built it as a pyramid because at the foundation of maintenance is what we call routine maintenance. Routine maintenance are practices that you do on a relatively frequent basis and on a regular schedule. So for example, you might be doing monthly routine maintenance or maybe twice per year or quarterly. It might even be every other year. It really depends on the practice itself and what maintenance it is. But routine maintenance is a regular occurrence that's relatively frequent compared to other types of maintenance. Things like visual inspections. We recommend visual inspection is done at least every year on all of your stormwater treatment practices. But really often we find that litter and debris removal kind of becomes a routine maintenance activity. It builds up pretty consistently and that should be removed. And vegetation management and ground cover management also is a regular, relatively frequent, routine maintenance activity if you want the practice to maintain its function, especially if it's vegetation-based. But then there are other maintenance activities that aren't as frequent or aren't as regular. You might say these are as needed maintenance activities, and that's what we call non-routine. These are things that you would do only when you need to do it. It's kind of the old adage that if it ain't broke, don't fix it. So these are maintenance activities you do when needed. Visual inspection will identify when these maintenance activities need to be done. And they'll include things like cleaning out trees and sediment from the practice, any structural repairs, or any partial rehabilitation. So ideally, these are activities that are relatively infrequent, especially compared to routine maintenance, and they're certainly not regular. If you have structural repairs on a regular basis, you might want to look at why you need those structural repairs regularly. More often, it happens as a result of some large event or catastrophic event or big storm, and it's not a regular occurrence. So that would be why you might want to do more inspections or do a little more investigation or assessment for why structural repairs are happening frequently at a particular site. But I do want to call out specifically trees and sediment. Sediment, again, will build up fairly regularly, but you don't want to go out and vacuum a sump or clean out an inlet every month or every other month if there's not enough sediment there to do so. You want to do it when it's at its capacity or near its capacity so that you're optimizing your maintenance activities and reducing the costs. And trees, we get into trees quite a bit when we do our inspection and maintenance training course. Trees are wonderful. I'm a fan of trees. I don't want you to get the idea that I'm not a fan of trees. I love trees. But trees in our stormwater treatment practices, if they're not designed to be there, can negatively affect your performance. There's actually a stormwater pond with an overflow bank, an overflow spillway, where a tree is growing in the overflow spillway. And that is dangerous because it is an embankment. And if that tree tips over, it will cause a breach of one of the walls, the barriers of our stormwater pond, and could cause the pond to fail. So the tree is good, but it's not in the right place. So it's often important to clean out trees when they're young trees, when, a vegetation specialist can identify it as a tree and remove it as a sapling before anybody else in the public can identify it as a tree, because as soon as it's recognizable as a tree, it can quickly become somebody's tree. And you certainly don't want to be removing trees that anybody has gotten any emotional attachment to. But that's routine maintenance. If we put together routine and non-routine and routine maintenance together, really, when you're doing that, you're doing preventative maintenance. And what are you trying to prevent? You're trying to prevent major maintenance. You don't want to get to the point where your practice is completely failing. And if you're doing routine maintenance on a regular basis and non-routine maintenance when it's needed, oftentimes you can push off major maintenance or even maybe prevent major maintenance indefinitely. That's the ideal situation. But obviously, we still see failures. So this is the maintenance pyramid. There are all instructions in the manual on how to do this. Lots of details, lots of guidance on what this means for each individual practice. So what are you going to find if you go into the manual and the resource guide? Here's a little screenshot of what it looks like. You're going to find a lot of sections on different types of practices because the maintenance and inspection is specific to certain practices. So, for example, you'll find a section on ponds and wetlands. One of the things we've added since the 2009 report is the floating treatment wetlands is a new section within this manual now. We have a section on underground sedimentation practices, which includes a variety of small and large practices that are primarily underground for settling particles. We also have infiltration practices. One of the new adds in an update to the manual is the tree box and tree trench, which have certainly become more prevalent in our urban landscapes. We can see it in many of our developments and stormwater treatment implementation projects. We have filtration practices where the new adds are amendments to our sand filter designs. So amendments in our sand filters can actually improve performance by capturing more pollutants. But that also means that's a potential failure mechanism. That's a potential component within the practice that will need maintenance. And you may need additional specific assessment to determine when those amendments are used up. And again, that's all guidance that's in the manual now today. We also have some existing case studies, Minnesota case studies of iron enhanced sand filters. So coincidentally, actually, so the previous version of the manual was released in 2009. We also installed, we being Minnesota in general, installed the first iron enhanced sand filter in full scale, went online in treating stormwater in 2009. So at the time the manual was written, iron enhanced sand filters were an idea. They were a concept. They were results from research. But starting in 2009, they became a full-scale practice. And today, there's over 170 full-scale iron-enhanced sand filters in Minnesota and beyond. So it's important to understand what inspection and maintenance activities are needed to keep them functioning in the long term. But we also have a section on bioretention practices, which includes rain gardens and infiltration basins. A new add to this section is the bioswales, which really are essentially drainage ditches, but they provide a lot of stormwater function, both in water quantity, slowing down the flow and providing infiltration, but also water quality in reducing pollutants. And they do need specific maintenance to remain functional in the long term. We also have full depth permeable pavement as a section within the manual, and this includes both concrete and asphalt, as well as interlocking pavements, block pavers, and things of that nature. And you will find case studies on stormwater harvesting. Stormwater harvesting and reuse is also a relatively recent new strategy in the stormwater field. We are seeing a number of implementation projects using stormwater harvesting and reuse. They are often very site specific. So we do have some generalized guidance for what you might want to look out for in terms of stormwater harvesting and reuse. But that is going to be very much so a site specific type of practice. So when you look in these sections, there's a lot of sections here and a lot of different types of practices. What are you going to find in each of these sections? You're going to find the benefits and the limitations of each of these types of practices. You're also going to find guidance on how to do assessment, whether that's visual inspection or point measurements such as capacity testing or field flood tests such as synthetic runoff testing or monitoring. You will also find maintenance triggers or the factors that are affecting performance. If you see a practice when you're doing a visual inspection that's not working well, you can use that assessment, whether it's visual inspection or capacity testing, to determine why it's not working well. And that will lead you then to what maintenance needs to be done. And that is what's through the rest of the section. It talks about what maintenance is needed and what you might expect to pay for maintenance. And the reason maintenance costs are important, as I said it in the beginning when I was explaining this to Herbert, that maintenance costs are often under budgeted. So if you want to have a budget that allows for proper maintenance of your stormwater facilities and infrastructure, you need a guide. You need expected maintenance costs to be able to develop a good budget. And so we try to provide that in this resource guide so that municipalities and other jurisdictions can begin building that into their budgets and then realistically being able to cover the most proper maintenance for their practices. But something else that's new in this particular version of the manual is a section on what we call management objectives. And really what we're trying to get to here is how can you meet your stormwater management objectives? You might say, well, I don't even know how to pick a bioretention or a wet pond or a sand filter. Or, oh my goodness, I just came into this job. I have all of these practices. I don't know what they're trying to do or why I'm trying to optimize them. But I know in my area, because I have TMDLs, total maximum daily loads, I know in those reports, we need to reduce phosphorus. So my goal is to reduce phosphorus. What this section does, if you look in the meeting stormwater management objectives, is you can look for the section on phosphorus reduction, and it will tell you then, what do you need to focus on within your stormwater treatment practices to maximize and optimize the phosphorus reduction for you to meet that stormwater goal. It's a very different perspective on how to look at stormwater treatment and your stormwater system as a whole. But it's not just phosphorus. So phosphorus is an example, but Millie was very adamant about saying that we can replace phosphorus with things like solids, phosphorus, nitrogen, metals, chlorides, pathogens, organic chemicals. You might have a different priority from phosphorus, and that's okay. There are sections of all of these pollutants within the stormwater management objectives section. So let's take a look a little bit at some of the guidance. I want to give you a taste of this. Again, there's way too much in the manual for me to cover in a relatively short webinar like this. So I want to cover a couple things so you get a sense of what you're going to find. We do have inspection checklists. We recommend inspections at least annually for all stormwater treatment practices. In this manual, we converted previously developed inspection checklists. We enhanced them, we expanded them, but we also converted them to be fully digital. They are PDF fillable forms now, which we're going to get to see here in just a minute. They are available for all of the different types of practices that you will find in the manual, but they are intended as a resource. This is a resource guide. So users, that's you can use them, you can edit them, you can copy them, you can amend them or change them to suit your needs. They're not intended to be a static thing. They're intended to be a resource that you can use and adapt within your jurisdictions for your needs. So please do so. We do ask that you give a little bit of credit where, and where we developed it. So you'll see here on the inspection sheet that we look at here shortly, that it does have the original source, but it gives you a place where you can take credit for your revisions and your changes to that. And then that will lead then to maintenance tables. Now, I don't expect you to read this. We're actually going to look at an example of this, but there are maintenance tables that go along with every single inspection form. So when you answer the questions, then you then would go to these tables and look for your answers and determine what maintenance you need to do in response to what you observed in the field. So this is kind of an example. Let's dive in. Let's really get our hands on this. And to do that, in honor of Halloween, we are going to do a spooky choose your own maintenance adventure. Many of you, if you're of my age and generation, you might remember the Choose Your Own Adventure books, where you would start reading and then you would get a choice at the end of a chapter, and you could choose this or choose that. And depending on what you chose, you would go to a different page. We're going to do that today with our maintenance activity. And so what we're going to do, here's the scene, if you will. You've crept onto a shadowy lane filled with BMPs, and you must choose one to inspect before you can move on to the next street. So which will you choose? Don't be too scared. It's okay. Millie is here to help us. And actually, Millie's friend Billy, the zombie dog, is also here to help, because there's a lot of options here. And I'm actually going to open up the poll and get this launched so that you can all vote on one of these practices. So what you're going to do is you're going to pick whichever practice you would like to see us do a little inspection and maintenance adventure on. And we're going to find out what your preferences are. So take a look at that. I know there's a lot of options. Billy is here to help us. Millie is here to help out as well. So choose which of these you would like us to dive into and take a look at. Oh, we're doing very good. It's a tight race. There's actually a lot of choices here. I see a lot of people picking a lot of different kinds, which is great. Again, we're not going to be able to look at all of them today, but if once you download the manual and take a look at it, if you have any questions on any of them, please feel free to reach out and we will be happy to answer those questions. My goodness, we have 100%. 100% participate, not quite 100%. We have 100%, 101, 111 responses. We have 81%, 82% participation. So I think they've leveled out so far. So we are going to end the poll here, and let's share results. Let's make sure I'm doing this properly. Hopefully you are all seeing the results. As you can see here, we got a very good mix. People are interested in a lot of different types of practices. Depending on timing, maybe we can take a look at a second one, but it looks like with a total vote of 21%, bioretention practices are number one, but a very close number two is 18% is our underground sedimentation practices. So very exciting. Thank you very much for participating in that. We are now, I'm going to stop the share. I'm going to close this out. We're going to get back to our presentation, and we are now going to find out what what maintenance adventure awaits us within the depths. So I'm going to switch screens over to the field inspection resources. I really hope you are now seeing a PDF. This is what you will find at the end of the resource guide. Is our field inspection resources section. It's kind of like an appendix. You will see here we have our field inspection forms in fillable PDF format. We have our maintenance activities based on those inspection forms. And at the very end, we actually also have some summary tables of additional maintenance recommendations and frequencies. But we're going to jump ahead right now. We're going to jump to the bioretention, our number one spooky pick here. And we're going to zoom in a little bit. I want to make sure you can read this a little. Nope, wrong way. Here we go. So in the bioretention sheet, you can see this is all PDF fillable. So if you make changes to it, you can fill that in. I've already kind of pre-filled a little bit of data here, but you can type in who's doing the inspection, what's the date, where is the inspection happening, and then you could go through the form. So has visual inspection been conducted at this location before? Yes or no? Maybe no today. Based on that, has any corrective? No, of course not. Has it rained in the last 48 hours? I don't know where you are all today, but for me, it definitely rained on me today. So I'm going to check yes on that box. And then this practice does have pre-treatment, and you might want to add notes here. You might want to talk about what your pre-treatment practices are, what you're noticing within those practices, et cetera. And even at this top form, you can actually take a picture of the site and you could upload that into the form so that it's included into your inspection. And ideally, what you would do is you would actually pull this form out and save as, because you're going to reuse this form over and over and over again. So you're going to save a blank one that you can continually update for each practice and for each time you're going out to the site. So normally these inspection checklists are roughly somewhere between 10 and 15 questions. It will ask about inlet structures. It'll ask about illicit discharge. It'll ask about vegetation cover for a practice that has vegetation. Bioretention certainly relies strongly on its vegetation. but it'll also talk about erosion, banks. It'll talk about the outlet structures and overflow structures or bypass. But ultimately, you will get down to the inspector's recommendations. At the end of the form, and again, with some experience and exposure to this, you'll be able to answer these kind of questions very quickly and assess the practice to determine, you know what, this practice needs maintenance right away. It has to happen before it rains again, or we could have a catastrophic failure. Or maybe not that. Maybe it's not that high risk before the next rainy season or within a year or two. And of course, you can be adding notes throughout. And then there's a section for the summary at the end. So once you do that, and again, this can be done by field crews with interns. Once you're done with that, you can actually then go to, for our bioretention practices, we can then look at what maintenance is recommended. And again, I'm going to zoom in here so we can read this a little bit better. But what you do here is you look at your questions, and then depending on how you answer, you can see the maintenance activities that you would want to recommend for the maintenance crews to do to address that issue. So for example, maybe you notice joint failures. Well, then you can figure out which joints, why the joints are failing, which ones are failing, the types of joints, et cetera, et cetera. Erosion or scour holes, you want to make sure and fill those in. You want to repair any erosion control that you might need in place, et cetera, et cetera. And again, you can go through these to really hone in on what maintenance is needed and when the maintenance is needed. So again, there's some indications here about timeframes of when you might need maintenance. So that's essentially what you're going to do. And again, it's very specific. It's very tied into both the inspection and your sites. So everyone's going to be different. When you do inspection and maintenance of stormwater treatment practices, it's literally a choose your own adventure every single time. So that's really kind of a preview of what to expect. That's how to use the guide and how to use the inspection forms. Let's go back to our maintenance adventure. And that's really all it is. It's really not that hard. It's not that scary. You shouldn't be afraid of doing this. It's something that can be done really relatively easily and quickly, but it can really provide a lot of benefit. And if you optimize that process, it will save you money in the long run. So I want to sum up. So in conclusion, the Inspection and Maintenance Resource Guide, it was published this past year, this past summer in June. It is online. There's a link to the CTS website where you can download that. Hopefully somebody can drop that in the chat if it's not already there. Please check it out. It does have a wide variety of stormwater practices. It has inspection, assessment, and maintenance resources, PDF fillable forms, which we just looked at, maintenance triggers, activities, frequency, and cost. And if this was interesting to you, if this was useful, I encourage you to sign up for our updates newsletter. And I can probably drop some links to that in the chat when we're done here. This is how we announce a lot of these types of resources and guides. As they come out, we make them available. We share them through our email newsletter. We also use our email newsletter to talk about the Minnesota Stormwater Seminar Series, where we invite nationally recognized experts in stormwater management and green infrastructure to give a keynote. And then they sit on a panel with local experts to continue the discussion and really answer your questions, the stormwater industry's questions on stormwater and green infrastructure. And I see here that Millie really wants to be a speaker in an upcoming seminar. So perhaps we can work that into the schedule for 2025. But with that, if I have any time, I would love to answer any questions you may have. I want to thank you for your attention. I want to thank Millie, the zombie cat, Billy, the zombie dog, and Herbert for assisting me with the presentation. Thank you so much for joining us today.
Thank you, Andy. I see we already have some questions, so I'll let Maurizio go through those.
So there's a question. Are the costs Minnesota specific, or could they be applied all over the US?
That's a great question. We put in Minnesota specific cost and it's it's date dependent. So I think they are $23, if I remember correctly. But we did put those kind of details in the report so you can adjust for your location and for whenever you end up doing these estimates. So for example, if you go into it next year, you would want to adjust from $23 to $25, for example. But yes, you can adjust them based on location.
And I want to remind the audience to use the raise hand feature to ask questions verbally, but if you prefer to type your questions, you can use that Q&A feature. So I'm going to read the next question. It says, is there a way to connect the maintenance to a broader watershed-based outcome? In other words, if you don't have a TMDL with specific pollutant reduction targets, how can you aggregate the reductions achieved by individual BMPs?
Yeah, that's a great question. And that can be a challenge. Managing stormwater at a watershed scale and thinking about pollutant reductions, and especially if you don't have specific numeric or parameter drivers. So numeric being, we want to get phosphorus below 40 micrograms per liter, or even parameters like phosphorus as a target. It can be difficult to really decide what to focus on. I would say you can use whatever management goals you have within your jurisdiction. So for example, if your particular watershed is you want to implement more green space, or you want to reduce flooding, or you want to restore natural hydrology, or if you want groundwater recharge, you can use those goals within the manual. You can look in the manual. It will explain what each of our practices do. So again, bioretention, for example, captures stormwater. They primarily infiltrate that stormwater into groundwater. They use vegetation to also provide evapotranspiration, microbial breakdown of different pollutants, vegetation uptake, and a variety of other multiple benefits. If you understand what your goals are and you look at each of these practices to understand what each of them do, you can then link those two together. So we didn't put in a specific section that's kind of big, broad goals. We do have kind of more specific goals, but you can use that as a framework to adjust and adopt it to whatever management goals you might have.
Same person asks, in addition to reductions, is there a way to assess or calculate the effectiveness of individual practices?
Oh, certainly. Yes, there's many ways. And we provide some guidance in there on how to do that. You may want to measure, for example, performance can be measured in a number of ways. You might want to measure infiltration performance, how much of a storm infiltrates, or how quickly can a bioretention practice infiltrate water. There are techniques and descriptions in this manual, and there are links actually to a bigger manual on assessment and maintenance that provides even more details on how to measure performance specifically, and then how to calculate that performance based on the measurement data you collect. So yes, there is guidance for that.
Let's give to private landowners who are responsible for inspecting and maintaining their own BMPs.
That's a great question. This manual was written with a target audience of stormwater professionals. And that doesn't have to be engineers. It could be stormwater managers, planners, watershed district folks, but it could be also stormwater engineers, consultants, state agency folks, et cetera. But it is meant really for someone that does have at least some background in stormwater and understanding of stormwater. That said, there is an introduction section that gives a brief overview of what stormwater is all about and why inspection and maintenance is important. So I do think you could share it, but private individuals, non-science-based or non-stormwater-based individuals may need a little more information, a little more context to really make the most use out of the guidance that's in this document. I also say that some of the maintenance recommendations will be potentially difficult or challenging for private homeowners, but that isn't to say that you could not contract that out. Many of the activities here actually could be contracted out by anyone. A watershed district might choose to contract out some of the maintenance activities that are recommended here within this. And that would also apply to homeowners associations or private homeowners or private landowners. Businesses may do that as well. So the guidance can lead to that.
Will costs continue to update with changes in the economy, or will costs stay at 2023 estimate?
That's a difficult question to answer. You can adjust the costs for inflation based on how the value of a dollar changes over time. But what we would need to do, and we actually, I think this is important research that should be done on a regular basis. I think what it costs to do maintenance should be reevaluated on a regular basis, because equipment changes, technology changes, lots of things about maintenance change over time. And if we are not regularly investigating that and updating our recommendations for what the costs are, then inflation simply may not account for all of those changes. So I do think that's important research. There isn't funding to do that on a consistent basis. We obviously pursue funding to do that as often as we can, but I think that's an important piece that should be done more regularly than it is today.
You mentioned new information on sand filter amendments. Is this focus just on iron, or have you included other amendments such as biochar and water treatment residuals?
Yes, there are other amendments in that section. There are Minnesota case studies of iron enhanced sand filters, but in the amendment section, other amendments are mentioned. It's not an exhaustive list because maybe some of you in the audience would know if you've looked into some of the research on this or some of the papers, there's actually a large number of amendments that people are investigating right now for implementation into rain gardens or sand filters or other stormwater filter type practices. And it would include biochar and other things. So there are amendments in there. It's not exhaustive, but you could use that at least as a starting point, and then look at what the recommendations are there, maybe find an amendment that's close to what your amendment is, or look into the literature to see if there's other specific recommendations for your amendment.
How were the recommended frequencies of inspections determined? Some different local government units, for example, city watersheds, have different inspection frequency requirements / recommendations.
That's a great question. So there's two ways that we've done this. So number one, as I kind of alluded to, we actually conducted a survey a number of years ago, and we actually reached out to all of the MS4, the Municipal Separate Storm Sewer System permit holders within Minnesota. And we sent a survey about their stormwater treatment, inspection, and maintenance activities. And so we gathered information. We actually got a very good response rate. I think we had close to 25% of respondents out of the people that we sent it to, which we thought was very good. And we got a good cross section of that range and variability in different maintenance frequencies, in different levels of effort that people put into maintenance, into different maintenance triggers. How often is, for example, sediment accumulation, why maintenance is needed, or litter and debris removal? How often is that the need for maintenance? So we gathered some very good information with this survey. And then we kind of ground truth that within some other contacts that we had locally to find out, is this realistic? And it represented the range very well. We do report ranges generally for some of these recommendations, so you get a sense because it is going to be site specific, watershed specific. But we also really emphasize that, again, inspection should be driving your maintenance activities. You can use a schedule at first, but you should use inspection to tweak and refine that schedule to be very specific for your area, your watershed, and even your specific stormwater treatment practices. So tune it in, get it very optimized for your site. You will, in the long run, save a lot of money because you're not going out to do maintenance when you don't need it just because it's on the schedule. And ultimately, I think you will have better performing practices and make your maintenance dollars go much further.
Are there ways to better incorporate stormwater considerations into construction design processes rather than the historical practice of just building a BMP and then forgetting about it until it does not work and a problem arises, since this has a huge impact on maintenance needs?
Yes, that's a great question. I've seen it successful in a couple of ways. Number one, oftentimes there's a maintenance agreement, or really there's an agreement with the contractor to ensure that it's functional for the first 2 years. So that protects against construction failures. And that's very powerful and very valuable because once the contractor's gone, and if it's not working right away, it can be very hard to get them to come back and fix it. So I highly encourage people to first have agreements with contractors so that they are maintaining and ensuring it's working in the first 1 or 2 years. And then number two, for the long-term maintenance, similar, I've seen agreements, whether it's with the property owners, if it's privately held, or within the jurisdiction, if it's publicly held, having a long-term maintenance plan. And then ensuring that whether it's public works or whatever department's responsible for actually doing the field maintenance is aware of and following along with these maintenance guidance. And again, it really starts with inspection. So if you implement an inspection program, start there. That will really drive when you need to do maintenance and what needs to be done. And that will ensure that it is getting done when it's needed.
It's hard to keep all the different proprietary underground filtration systems straight when it comes to inspecting them and how they function. What is St. Anthony Falls Laboratory seeing for inspections and maintenance of all of these and coming underground systems?
Ooh, what have we seen in common is what we've seen in common in general is most of these underground practices. I want to separate, I guess pun intended, hydrodynamic separators. I want to separate small chambers from large underground structures. Okay, let's start with small chambers first. Things like hydrodynamic separators, sump manholes, catch basins that might be hydromodified, things of that nature where the relative size of it is small. For those practices in general, we can see them fill up very quickly. So the maintenance needs are often underestimated. I know some places that actually will go out and vac truck their sump manholes, their hydrodynamic separators, almost on a monthly basis because that's how quickly they fill up. In many other places, they might only vac them out once a year and they're always full because they can fill up very quickly. Obviously, it depends on how many of these you have, how much sediment's in the watershed, et cetera. But in general, I see that these small underground chambers are not maintained frequently enough. The other general observation is they're not inspected enough. Again, another old adage, out of sight, out of mind rings true. These things are underground under a manhole. It's very easy to forget they're there. And so it's very easy to forget to do the inspections and find out when they're getting full. So I highly recommend people do more inspections. You might have to do even more frequent inspections on these underground chambers, especially the small ones, more frequently at the beginning to really establish that maintenance frequency that's needed for those practices. When we talk about larger practices, things that you might see at the scale of a parking lot or a baseball field, these larger underground storage structures and treatment structures, I would say you do want to still inspect them frequently in the beginning to understand if their pretreatment is filling up quickly or how quickly that's filling up. So again, that would be a similar, not as maybe frequent as needed as the smaller ones, but these big ones still need to be inspected. And in general, out of sight, out of mind is also true for these. So make sure they're being inspected. That would be my biggest recommendation for those underground structures.
To the last two questions. Based on the Minnesota experience, what are some of the most challenging maintenance issues concerning vegetated facilities?
Oh, so the most challenging, oftentimes it's understanding. So there's a couple. Number one, some of these practices, again, depending on your watershed and depending whether you have pretreatment or not, some of the vegetated systems can receive just too much sediment. It doesn't happen very frequently, but if you get too much sediment, especially at the beginning of a practice's life, then the vegetation really can't establish well. It can get buried and it won't grow up. If you have healthy vegetation, even if you have a pretty good sediment load, oftentimes the vegetation can keep the pores open and you can still get good infiltration in your basins that are vegetated, even though there is a sediment load. But that can be one challenge, is in some places, if you don't let the vegetation grow up well in the beginning, it just may never get off the ground. Number two, maintaining healthy vegetation, I think, is the biggest challenge. And I've seen some designs where they want to make it very beautiful, very aesthetically pleasing, and use a lot of different types of plants. If you don't have a plant expert to maintain it, they're not going to be able to tell the difference between the weeds and the natives or the desirables. So that's a really big challenge with these vegetated systems, is you have to understand who is responsible for maintaining them and design the system for that maintenance. Think about, again, who is your audience? Who's the person that's going to be in charge of this in the long term? If it's a private homeowner or a homeowners association, you may have somebody that loves plants and knows all these plants and they can do this, but they might not be able to do it forever. So you got to make sure that they, whoever is maintaining this practice understands what needs to be done and how to differentiate between the different vegetation. So I'd say those are the two biggest challenges, making sure that they get established, the vegetation is strong and healthy throughout, and that whoever is maintaining it knows what to pull and how to maintain it and what vegetation needs to be there.
The costs consider economies of scale, both related to the size of an individual practice, for example, large versus small practices, and at a programmatic scale, for example, if multiple BMPs at different sites can be maintained during the same day/trip.
Yes. So both in terms of cost and effort. So if you go into the details on the cost data, and you probably, I don't know if we included the background data for the cost. I think we just provided the cost recommendations. But if you look at the references that those recommendations cite, you're going to find a paper or a report that has all of the details on how we determine those costs. And there is an economy of scale between small practices and large practices. You actually do save some money as the practice gets larger, because most of the cost is actually getting to the site rather than doing all of the work. So there is economy of scale for larger versus smaller practices. And there is relative effort differences. So how many person hours are required to do different types of maintenance activities? And you can certainly schedule and optimize that such that you might be able to do multiple activities at a particular site all in one day, or you might be able to visit multiple sites all in one day and get a lot done. And I would say for inspections, again, I don't know if I gave any numbers for this, but inspections, generally, most inspections can be done in less than 30 minutes. So honestly, if you have a field crew doing inspections, you can get a lot of inspections done in a day, in a week, and even in a summer. So there is guidance for that. There is information on that. It does have an economy of scale.
We received two more questions. Are you okay if we answer them?
I'm fine. Yeah, I can stay as long as you need.
Awesome. Have you considered, or will we be able to associate the maintenance regime with the size of the catchment draining it? Say, as a function of so-called I/P ratio, with this being footprints?
Yes, that's a great question. So the so repeat. So I guess yes, you'll have to understand what those watershed characteristics are. I honestly think if you're doing inspections, you might not need to know them. You could get a good estimate based on how much impervious surface there is compared to your treatment area. You could do some estimates there, but if you're doing inspections, you could maybe bypass that process. It's a good practice to do. It's a good to understand it. That gets to the design side. And I've actually seen that recently where a number of practices are designed way smaller than what I would recommend they be. They're getting too much impervious surface. They're getting too much water, too much sediment, too much material coming into them, which means you're going to have to maintain it more frequently. So that's the trade-off. But if you do inspections, you will know how often they need to be maintained. If you want to improve your maintenance, meaning improve, reduce the costs, not have to do quite as much maintenance, reduce that maintenance burden, then it will go back to design and look at what's your watershed characteristics, what are the impervious areas, how big should these practices be, and really make sure that we're not undersizing our practices on the design side. So there's kind of two ways to go about it. You could look at design and do a feedback loop, or you could really just focus on inspection and make sure that you're inspecting them frequently enough to catch maintenance activities and maintain them as frequently as you need to.
Last, do you have any maintenance recommendations related to road salt loading, especially in vegetated systems where salt may impact plant growth?
Yeah, vegetation and salt, road salt is a big issue. So again, that gets to a little bit on the design side and also the maintenance side. On the design side, in places in cold climates like we have here in Minnesota, there's actually design guidance for salt tolerant plants. And so picking the right plants for your location, if you feel like or think it's going to get a lot of road salt, I would choose those salt tolerant plants to just at least give them another chance to survive and be able to withstand some of those salt loadings. So there's the design side. You can choose plants differently. On the maintenance side, perhaps it's too late. Maybe a site was designed and the designer didn't realize how much salt this particular practice was going to get, or that site was going to administer to the impervious surfaces. In that case, you can watch the vegetation, you do your inspections. As part of your vegetation management, you may need to replant. And whether that's reseeding with salt-tolerant plants or doing plugs of salt-tolerant plants, that could become one of your maintenance activities to ensure you have strong and healthy vegetation throughout the practice and ensure that it doesn't become a victim of that problem that you saw in the first round. So I also do recommend that your maintenance should adapt to the situation. If you are seeing in your maintenance and your inspections that something is happening frequently that you don't think should happen frequently, use that inspection to think about the cause and try to address the cause. You can adjust your maintenance or your activities then to either counteract that cause or remove that cause so that that doesn't continue to be a maintenance burden on those crews. So again, take what we have here in the resource guide, look at what it is, look at the recommendations, understand what's going on, adapt and adopt to get your maintenance activities to be as optimal as possible. And that will save you money in the long run.
Lonnie, thank you so much. Thank you for answering all of our questions. This has been a wonderful presentation, and I think I have learned so much. My only feedback to you is that the zombie cat was a little too spooky, so
I won't tell her.
I think we will now move to the next section, which we call the round robin. But thank you, Andy. I don't know, Beth, if you wanna.
Thank you so much.
Yes, thanks, Andy. So basically, we kind of round out these webinars after our presentation by just checking in with folks and seeing if they'd like to discuss anything that they're maybe experiencing at their organization. So we have a couple, questions to tee up the conversation. So I'll just start with the first one. What current transportation issues related to environment and energy or transportation infrastructure are you and your organization facing currently? Daniel, I'm not sure if I can unmute you. Sam, are you able to?
Okay.
I have pressed ask to unmute.
Okay, maybe James, you can help us to unmute.
Same thing. Daniel, we've asked you to unmute, but I think you need to do it from your end.
Okay. It flashed for a second that you were unmuted, Dan. Oh, I think it's still preventing him somehow from unmuting. There we go. Hopefully you're green.
Yeah, I accidentally raised my hand.
Oh, okay.
Yeah, can you speak now?
Yeah, I can, but I didn't have a question.
It was an accident. So here's another question that could maybe prompt some discussion. Do you have any organizational, informational, or event updates to share? I guess one update that I could share that might be of interest to this group is the American Public Works Association has their fall conference coming up here very shortly. It's held in November on Thursday, November 21st and 22nd at Mystic Lake Event Center. There's more information on APWA's website, which is, I believe, apwa-mn.org. You'll find a full program there for those 2 days where you can gain, credits for your licensure and many great presentations from keynote speakers and practitioners. And I'm sure there'll be really interesting stormwater discussions at that conference. So just a plug for that event coming up.
But I will add that don't forget November 7th is the CTS Research Conference. It's a amazing conference. I've been going for that for years, and always amazing food too, so don't miss it.
A chance to be on campus. So here's one more question. What ideas do you have for potential future council meeting topics or speakers? I know all the councils are very interested. If folks have, topics they'd like to touch on, either from an environment, an outreach, just infrastructure, all transportation related, we're definitely always taking suggestions. Sounds like we don't have any talkers today. Maybe everyone just wants to get on to see if it's snowing where they're at. And then to the Halloween festivities, which, snow and Halloween, not ideal, but thank you guys for joining today. We really appreciate CTS setting up this event and for Andy for doing a great job presenting. So thank you all for attending and all the great questions.
Thank you, everyone.
Bye-bye.